Hello dear students, how are you? I hope all are fine. Okay, today let me discuss a very important concept, that is, crisscross method. Before discussing about crisscross method, first let me discuss about ions, and their formation with the help of valency and oxidation state. Okay, first let me discuss about ions. Ions are also called as radicals. Now what are the ions? The charged species are called ions. Example: Yen-3, O-2, Yaf-1, Yen-Ye+1, Yem-G+2, Ye-Yel+3, O-Yech-1, CO3-2, PO4-3. And so on etc. Now let me discuss about classification of ions. Ions are classified into two types. They are, first one is, simple ions, or monoatomic ions. And, second one is, polyatomic ions, or compound ions. Okay, first let me discuss about simple ions or monoatomic ions. What are simple ions? The charged species that are made up of a single atoms are called simple ions. Again, simple ions are two types. They are cations and anions. Cation means the positively charged species are called cations. And anion means the negatively charged species are called anion. Some examples of cations are Yen-Ye+1, it is called sodium ion. Yem-G+2, it is called magnesium ion. Ye-Yel+3, it is called aluminium ion. K+1, it is called potassium ion. Ca+2, it is called calcium ion. And so on etc. Some examples of anions are Yen-3, it is called nitride ion. O-2, it is called oxide ion. Yaf-1, it is called fluoride ion. Yes-2, it is called sulfide ion. Cl-1, it is called chloride ion. And so on etc. Now let me discuss about polyatomic ions or compound ions. What are polyatomic ions? A group of atoms that carrying a charge are called polyatomic ions, or the ions which consists of more than one type of atoms are called polyatomic ions. Polyatomic ions are again two types. They are cations and anions. Now let me give some examples for cations. Yen-Yech+1, it is called ammonium ion. And so on etc. Now let me give some examples for anions. O-Yech-1, it is called hydroxide ion. NO3-1, it is called nitrate ion. CO3-2, it is called carbonate ion. HCO3-1, it is called bicarbonate ion. SO4-2, it is called sulfate ion. SO3-2, it is called sulfite ion. CH3COO-1, it is called acetate ion. PO4-3, it is called phosphate ion. And so on etc. Now let me discuss about how these ions are formed. To know about it, we have to focus on valency concept. Now let me know, what is valency? Valency has 4 definitions. Now, the first one is, the combining capacity of an atom of an element is called valency. It means that one atom can able to combine with how many atoms, it is nothing but valency. Simply, how many bonds an atom can form with other atoms is called valency. Actually, in the universe, there are 118 elements. Out of these elements, only few elements are stable. Mostly, inert gases are stable. Remaining all elements are unstable. So all these unstable atoms will get stability by combining with other atoms. That combining capacity is called the valency. For example, octopus has 8 hands, it will combine with 4 humans. Here, we have to count the number of hands that are joined each other with how many human hands octopus combined is called the combining capacity of octopus. It means that octopus joined with 8 human hands. So, the combining capacity of octopus is 8. So the octopus valency is 8. And each human combining capacity is 2. So the human valency is 2. Now, the second definition is the number of unpaired electrons, or single electrons present in the outermost shell, or valency shell, or last shell of an atom of an element, is called valency. In chemistry, we give more importance for only electrons but not for protons and neutrons. Because all chemical reactions can take place due to only electrons but not protons and neutrons. In that electrons also, chemical reaction takes place only due to outermost shell electrons. In that outermost shell electrons also, the chemical reaction takes place only due to the presence of unpaired electrons, or single electrons. Innermost shell electrons cannot participate in the chemical reaction. Because innermost shell electrons are very near to the nucleus, so innermost shell electrons are strongly attracted to the nucleus. So, these innermost shell electrons cannot participate in any chemical reactions. So, outermost shell electrons are only responsible for the formation of chemical bond, rather than innermost shell electrons. For example, nitrogen atom, atomic number is 7. It has 7 electrons. Nitrogen electronic configuration is 1s2, 2s2, 2p3. K shell has 2 electrons, and L shell has 5 electrons. The last shell is called outermost shell. So, L shell is the outermost shell of nitrogen. In the outermost shell, the total number of electrons are called valence electrons, and the only unpaired electrons in the outermost shell is called valency. So, nitrogen valence electrons are 5 and nitrogen valency is 3. Now, the third definition is the same number of hydrogen atoms, or double the number of oxygen atoms, that an element combines with it, is called valency. For example, in methane, 4 hydrogens are combined with 1 carbon. So, the valency of carbon is 4. And in magnesium oxide, oxygen combined with 1 magnesium atom. So, we have to double it. Then the valency of magnesium is 2. Now, the fourth definition is, according to new concept, valency can be explained as the number of electrons gained, or lost, or shared, with one atom to another atom, to get its nearest inert gas electronic configuration. Actually, in the universe, there are 118 elements. Out of these elements, only few elements are stable. Mostly, inert gases are stable. Remaining all elements are unstable. Because they have more energy. If these atoms lose energy, then these atoms will get stability. Because energy and stability both are inversely proportional, atoms will lose the energy by gaining, or losing, or sharing the electrons. Here my question is, how can you know that, whether an atom can gain, or lose, or share the electrons? It depends upon the nearest inner gas electronic configuration to that atom. For example, sodium is unstable atom. Sodium nearest inert gas is neon. So, to get stability, sodium will lose 1 electron and will get neon inert gas electronic configuration. So, sodium forms Na+1 ion. Similarly, all remaining atoms will form ions. in the same manner. Note: inert gases cannot lose, or gain the electrons, from any element. But, because of inert gases only we can know how many electrons an element can gain, or lose. Valency formula is 8 minus group number. Now let me discuss about oxidation state. What is oxidation state? The charge present on the atom or group of atoms is called oxidation state. For example, the oxidation state of Na+1 is +1. The oxidation state of Mg+2 is +2. The oxidation state of OH-1 is -1. The oxidation state of CO3-2 is -2. And so on, etc. Once look at this table to understand about valency and oxidation state. Now, let me discuss about Criss-cross method. By using Criss-cross method, we can write the formula for the ionic compounds. In this method, there are some rules. First let me discuss about those rules. Rule 1. First write the symbol of an element with their oxidation state. Usually, first we write cation followed by anion. Rule 2. Leave the charges of cation and anion. Rule 3. Exchange their valencies, oppositely to the subscripts of the atoms. Rule 4. If in the subscript, number 1 is present, then we have to ignore it immediately. Rule 5. If in the subscript, same numbers are present, then we have to cancel them with the suitable table. Rule 6. We don't keep bracket for the simple ions. We keep bracket for only polyatomic ions subscripts having more than number 1. Rule 7. If in the subscript, the numbers 2 and 3 are present, then we have to call them as twice and thrice. For example, let me write the formula for sodium chloride. First let you write, the symbol for the sodium is Na and its oxidation state is +1. And chlorine element symbol is Cl, and its oxidation state is -1. Now leave the charges. Now exchange their valencies, oppositely to their subscripts. Now the subscript has number 1, then we have to ignore it. Then, the final formula for the sodium chloride is NaCl. In the same manner, let me do the following examples also. They are magnesium sulfate, its formula is MgSO4. And next, calcium phosphate, its formula is Ca3PO4 twice. And next, aluminium nitrate, its formula is AlNO3 thrice. And next, sodium carbonate, its formula is Na2CO3. It is called washing soda. And next, sodium bicarbonate, its formula is NaHCO3. It is called baking soda. Okay, now let you fill this following table, and try to write without seeing. If you have any doubts then, write in comment box. I will give answer to all your comments. Okay dear students, this is the today's class. If you like this video then please press the like button. And for more educational videos, please subscribe our channel. And share to your friends and make them to subscribe also. Thank you.